Hey everyone, welcome back to TechOps tutorial. In today's session, we are starting with the basic of Kubernetes storage. This is a part 1 of our volume series where we will focus on EmptyDir and HostPath volumes. If you are just getting started with Kubernetes, this guide will help you to understand how container handles the storage and why volumes are so important. So let's get started. Before we start, let me quickly walk you through what we will cover in this session. First, we will talk about the problems with container storage and why data handling inside the container can be tricky. Then we will see why volumes are needed and the benefits of using them. After that, I will explain what volumes actually are in Kubernetes along with their lifecycle basics. We will also look at the different types of volume, but in this part, we will keep it simple and focus on EmptyDir and HostPath volumes. Finally, we will wrap up with when to use these volumes, followed by quick summary and what's coming next in part 2. Let's move to the next slide. Now let's talk about one of the biggest challenges with container storage. By default, containers stores data in their own writable layers. The problem is this storage is ephemeral, which means if a container restart, all the data which is inside will be gone. Think about the impact this can have in a real life. A database container could lose all its records. Log files may vanish when the apps restart. Even user uploads can disappear instantly. So clearly, relying only on a container storage is not reliable. We need a better way to handle the data in Kubernetes. Let's move to the next slide. So why we need volumes in the first place? First, volumes gives us a way to separate the lifecycle of the data from the lifecycle of the container. That means even if the container goes away, the data can still remain. They also make it possible to share the data between multiple containers inside the same pod. For example, one container could generate a log files while the another container processes them, both using the same shared volumes. Volumes also ensures data stays alive as long as the pod is running, and most importantly, they allow data to survive container restart. In short, volumes solve the storage problem we saw earlier in the previous slide and make a container much more practical for the real world application. Next. Now let's quickly look at the benefits of using volumes. The first one is persistent. Your data survives container restart and even pod rescheduling. Next, volume brings a separation of concerns. By decoupling the application data from the container image, we make our application more portable and easier to manage. They also provide scalability since we can provision the additional storage as workload grow. And finally, volumes enable data sharing. Containers within a pod or even across a pod can access the same data for collaboration and persistence. This benefits makes a volume a core building block in Kubernetes storage. Next. So now that we know why volumes are important, let's define what a volumes actually is in Kubernetes. A volume is simply a directory that containers inside a pod can access. This directory can be a temporary, used only while the pod is running, or it can be a persistent, surviving a pod restart and rescheduling. Most importantly, volumes are mounted into a container at a specific path. That means applications don't need to worry about where the data is stored. They just read and write to that directory. In short, volumes gives a container a stable and reliable way to handle the data. Volumes in Kubernetes also follow a life cycle, and it's important to understand how they behave. If you look at the diagram here, notice the ephemeral volume is directly attached to the pod. This means If a container inside the pod restarts, the data in the volume is still available. But once the pod itself is deleted, the ephemeral volume also disappears along with it. Now compare that with a persistent volume shown in the diagram. Unlike ephemeral volumes, it exists independently of the pod. So even if the pod is deleted, the persistent volume and its data remain intact. To put it simply, ephemeral volume lives and dies with the pod, and persistent volume survives beyond the pod's lifecycle. We will dive deeper into persistent volume and how they are managed in the part 2 of the series. But for now, just keep this a key distinct in mind. Next. Now that we understand the basic of volumes, let's look at some common types you will encounter in Kubernetes. First, we have the EmptyDir. This is a temporary storage that creates when a pod starts and is deleted when the pod goes away. All containers inside the pod can read and write to it. Think of it like a scratchpad or a whiteboard in a meeting room. Useful while the meeting is happening, but wiped clean once the meeting ends. Next is HostPath. This mounts a directory or a file from the node file system directly into your pod. It persists even if the pod is deleted. But there is a catch. It's tied to a specific node. Imagine keeping some files in your Office desk drawer. They will stay safe as long as you keep working from that desk. But if you move office, you cannot take them with you. Finally, we have a persistent volumes. These are cluster-wide resources independent of any single pod or node. They are claimed using persistent volume claims, PVCs, and can be backed by a various storage system like NFS, Cloud Disk, or SAN. Think of this like storing your files in a shared company server or a cloud drive. No matter which laptop you use, you can always access your files. To summarize, EmptyDir temporary pod lifetime storage, host path tied to a node file system, persistent volume, cluster-wide independent and long-term storage. So always choose the right volume type based on how long you need that data to persist. Let's move to the next slide. Let's talk about the EmptyDir. An EmptyDir is created when the pod starts and it's deleted when the pod ends. It lives on the node file system that can be a disk or a memory depending on how you configured it. What's it good for? Temporary cache while your app runs, scratch space for computations, intermediate files during the processing. It's important to remember this is not for long-term storage. If you look at the diagram, the temp storage bubble is attached to the pod. Exactly why we say pod lifetime equals to a volume lifetime. When the pod goes away, this storage goes with it. A simple way to think about the EmptyDir, it's like a scratch folder on your desktop. It is handy while you are working, but you don't rely on it to keep important files forever. Next, we will see HostPath, which can keep a data on the node even after the pod is gone. Next, let's talk about the HostPath volume. This type of volume mounts a specific path from the host machine directly inside a pod. Now, where do we use it? It can be handy when you need access to the host system logs. Sometimes you may want to use pre-installed tool that already exist on the host. Or if you have a node specific configuration files, HostPath can help you to make them available inside the container. But here is the catch, it comes with risk. First, it's a node specific, which means it's not portable across cluster. Second, there are security concerns. Giving a container direct access to the host file system can be dangerous if you not handled carefully. That's why HostPath is generally avoided in production unless it's absolutely necessary. In short, HostPath gives you a powerful access, but you should always use it with caution. Next. Now let's compare when to use these volumes. If you need temporary storage like caching, scratch space, or data that only matters while the pod is running, then EmptyDir is the right choice. It's safe, but remember, the data disappears once the pod is gone. On the other hand, HostPath is used when you need access to the node specific files such as system logs or pre-installed tools. The data lasts as long as the node has it. But this comes with a warning. It's considered risky because it gives a container direct access to the host file system. So choose the right volume type depending on your requirements, safety and portability with EmptyDir or host level access with HostPath. Next, let's quickly wrap up what we have learned so far. First, remember that the container storage is temporary. Once the container is gone, its data is gone too. That's where volumes comes in and solve the problems. We look at EmptyDir, which provides the temporary storage that lives only as long as the pod runs. Then we explored HostPath, which lets you to mount a folder from the host directly into your pod, but this needs to handle carefully because of portability and security risk. And finally, this is just the beginning. In part 2, we will dive into persistent storage, things like a persistent volume, PVCs, and storage classes, along with some real-world deployment example. Next. And that's bring us to the next step. From here you can watch the next video. We will show you a live demo of EmptyDir and HostPath in action. After that we will move on part 2, where we will cover a persistent volume, PVCs, and more advanced storage concept. Don't forget to try out the hands-on practice with the example. If you found this video helpful, make sure to subscribe and hit the bell icon so you don't miss the upcoming tutorials. Thanks a lot for watching, and I will see you in the next one right here on the TechOps tutorial.